Okay, so still in 1.8, and we're going to do 10, 11, and 12. So number 10, it's asking, it just has all these directions. So identify the type of sequence, determine the recursive and explicit for each sequence. And then if it's not, then identify whether it is or not. Okay, so the very first thing that I'm going to do is I'm going to look at the numbers for number 8. And oh, 10, 11, 12, sorry. Sorry, for number 10. So the very first thing I'm going to do is I'm going to look at these numbers, and I notice that it's minus 30, then minus 15. So it's not arithmetic because it went minus 30 and then minus 15. And in order for it to be arithmetic, it has to be subtracted by the same number. Then for geometric, right? For geometric, what I need to do is I need to divide and see if it's the same number. Well, as I do that, I notice that 30 divided by 60, and I always go right divided by left or bottom divided by top. So 30 divided by 60, and I'll write this up here. 30 divided by 60 is 1/2, which is the same as 15 divided by 30, which is the same as 15 over 2 over 15, right? All of these are exactly the same. I know this one looks really, really weird because it's a fraction, but even if you think like, if I divided this by 2, oh yeah, it's 15 over 2. Okay, so all I'm saying is this is my common ratio. So this implies common ratio, and he's the star of the show. That's what I keep saying. He's the star of the show. You'll see him showing up over and over again. I'm going to use the simplified version of him because then that makes the most sense. When I write my recursive equation, I don't know which one you prefer, but for me, recursive equation makes sense in my head to move to next because I just talked about it. So the very first thing I do when I write my recursive is I write my first term. So f of 1 is equal to 60. And then I write f of n, which is the next term, is equal to f of n minus 1, which is how I say previous term. Uh-oh, it's not catching up to me. I'm sorry. Let me let the computer catch up. So the recursive function, the very first thing that you do is you always write the first term. Technically, you can write whatever term you want, but I always do first term because that makes the most sense to me. So f of 1 equals to 60. And then f of n, this is how we write the word next. And this is how we write the word previous, right? And then what are you doing every single time? Well, I'm multiplying by half. Ms. Johnson, I thought you said dividing by 2. So multiplying by half and dividing by 2 is the same thing. It just looks different, right? Just looks different. So here, that's my recursive function. And my explicit equation, some of you have been noticing that there is a trend to it. There is a structure to it. So here's the structure that I know. My structure in general for geometric looks like this. It looks like something times something to the something. I know that's really ambiguous, but in reality, that's exactly the structure. So what I do is I figure out what number goes in each of these, and then I check my answer. So I already know that the half goes right here. He's my multiplier. So he goes here, and I put him in parentheses because I want the whole thing being taken to that exponent. Okay. And then this guy here tends to be your first term. So I'm going to put 60 there. So let me highlight my 60 and I put that 60 there. Let me highlight my yellow because he's my common multiplier. And then last but not least, I put my exponent, which for the most part, it is usually n minus 1. So I could be very wrong, but now what I do is I just take my handy dandy calculator. Even better, I'm going to take my graphing calculator because that's my favorite, right? And then I'm going to plug in this and I'm going to check one of these. So I don't know why, but it's still not saying n minus 1. I promise you it says n minus 1. Just give it a second. So I'm going to go like this, 60 times, and then parentheses 1 divided by 2. Oops, 2. And then I'm going to take it to the n minus 1. So parentheses x minus 1. Okay, so there's the function. I really don't care about it, but the very thing that I want to do is I want to start plugging in numbers. So if I plug in 1, I should get out 60. Let's see. Oops. Yay. So if I plug in 2, I should get 30. Yay. And if I plug in 3, I should get 15. Yay. So therefore, my answer is perfect. I won't, you know, like on a test, I'm very satisfied. Miss Johnson can't take any points away from me. Look, I've shown all my work. I've explained all my thinking. It's all there for Miss Johnson to check my work. Okay. Moving on. So it says the number of black tiles in the sequence. So the number of black tiles. So how many black tiles are there? That's what they're saying. So here there's 1 black tile. Here there's 2. Here there's 4. And you can kind of already see how that sequence is going. I already know it's not arithmetic because it goes +1, then +2. That doesn't make sense. This looks like a geometric sequence because look, it goes times 2 times 2. So yeah, this is actually geometric. And so here I know this because my R equals 2, and R is a shortened version of common ratio. Okay, so with that being said, I'm just going to follow these structures that I just wrote up here and see if it comes out the same. Okay, so here my f of 1 is 1. My f of n equals to f of n minus 1 times 2, right? Let me let my computer catch up to me. See, I'm faster than a computer, y'all. Okay, so then the explicit equation, I'm still going to use this structure. Okay, I'm still going to use this structure. The first number here is that 60. Oh, it's just the first term. Okay, so it's equal to 1 times, right? And then this number here is my multiplier, which in this case, it's 2. So 2, and then I put to the n minus 1. And then I'm going to check my work to make sure that I'm good, and then I'm good. Okay, so I'm going to change this all so that it says 2. I'm going to change this to the number 1. So 1 times 2, I'm going to plug in the first term. It should be 1, yay. I'm going to plug in the second term. It should be 2, yay. I'm going to plug in the third term, and it's 4. So yay, I did this perfectly. Okay. Okay. This next one, as I continue through, I'm going to check to see if this is arithmetic first. I don't know. I think I check in my brain. The list I go through is first, are you arithmetic, or then are you geometric? If the numbers change rapidly like this over here, I instantly go to geometric. So this one here, I'm going to just see this is +3 plus 5 and then +7. So it's not arithmetic. So no, it's not arithmetic. And then I'm going to write these as fractions and see if they're true. So I do right divided by left. So that's 7 divided by 4. Is that equal to 12 over 7? And that doesn't look equal. And if you don't know if these are equal, then you take out your handy dandy calculator and you simplify them. Okay. So here's my handy dandy calculator. And I'm going to check 7 divided by 4. Oh, that's 1.75. Cool. Then I'm going to go 12 divided by 7. Wait, that's 1.71. So it's not geometric. Oh, okay. So it's neither. So how did I know that it was neither? Because it wasn't a constant difference, +3 plus 5 plus 7. And it wasn't a constant ratio because 7/4 doesn't equal to 12/7, right? So because of that, I don't have to do this. That's according to what this says. It says, identify the type of sequence and then determine the recursive and explicit for each. If the sequence is not arithmetic, just identify it as neither and don't write the equations. Okay, so there you go. I hope that makes sense to you. If you haven't used this structure before, continue using the table and hopefully that makes sense. Have a great night.